So welcome back, everybody. I hope you managed to enjoy some lunch. And welcome back to this afternoon's session, where we have two presentations before we go on to the roundtable session. For the first session, it's a great pleasure for me to introduce to you Professor Andry Rakotonirainy from the Centre for Accident Research and Road Safety at Queensland University of Technology in Australia. And Andry's title is a human-centric explainable automated vehicle. Andry.
Thank you very much, and thank you for inviting me. It's a pretty tough gig to present after lunch, so I will try to do my best. The title of my talk is a human-centric explainable automated vehicle. Just to give you a background, I'm working for University in Australia. My center is located in the Faculty of Health and School of Psychology. And you will see through my talk that there is lots of, I would say, concept from the human factor point of view, as opposed to, I would say, the engineering-centric type of work. So this is the outline of my talk. I will talk about human-centered AI and the AV, automated vehicle, and then I will talk about the explainable artificial intelligence, XAV, for automated vehicle that are called XAV. So I think I don't need to convince you that AI, especially deep learning and neural networks, have become an absolute necessity to make AVs function proper, acceptable, and also safe. I'll dig straight away into some issues that I see with AI, generally speaking. We know that sometimes they are coming across as a black box, opaque. They are seen as complex, and I think I will just cite what one of the, I would say, expert in machine learning, Yann LeCun, Facebook, he said, it's a complex. It's not that everything is hidden with deep learning. He said something along the line of, even if you look at the source, if you look at the code, you can't understand why you have the result because it's too complex. So from the user point of view, sometimes it's very much not predictable. There is no explanation about why that black box arrived to some explanation. There's lots of work on how do you trust it, how do you accept it. You probably heard about a bias. When you use large data, it actually amplifies social bias from which that data has been collected. There's a lot of things about the ethics issues, problem about when that black box or the AI result give you something, it's very hard to verify the claim or the result of that black box. I will just stop there for the issue with AI, but I would say the flavor of my talk is really to look at the user point of view. We tend to look at the one-way dynamic between users and AI, meaning that we just ask the AI to do something and that's it. From the human factor point of view, we want to trust the result of that AI, especially if the result is used in some kind of critical type of decision making, such as in automated vehicle. We want to make sure that the result given by that AI has some ethical compliance or ethical purpose, that it is technically robust, and last but not least, it's auditable, meaning that you can trace back and verify why it has been provided such a result. And sometimes when there are some approach which advocate the fact that if it's not auditable, then it needs some sanctions. Now, why do we need AI to explain itself? It's because we have the unambiguous right to seek meaningful information about the existence of some logic within that box. And we need to understand some consequences of why this machine made one decision or the other. And this is a statement from the OECD that I just wanted to show. If you look at the US National AI R&D, and our colleague from the US here might know about this. This is an extract of the strategy in AI. As you can see, the most important things that I want to highlight here is that AI community should develop effective methods for human AI collaboration, and it has to understand and address the ethical, legal, and societal implications of AI. And if you look also at what Google is trying to do in terms of regulating AI, they say something along the line of it has to be accountable to people and it has to be transparent. This is a quote from Microsoft. With regard to transparency, again, we want to be able to verify the result of the claims of an AI and trace back steps leading to a final decision, and also adopt best practice for ethical principles. So avoiding biases or avoiding fake news. This is the kind of things that we want to have. Now, I mentioned to you that sometimes it comes across like a black box with an agent just doing making some decision. What we really want as human is to answer the question, what kind of explanation are truly human interpretable? This is the phase which is really poorly addressed in AI. So we want to have some explanation as to why. So we try to mimic what the people are doing when they are reasoning about something. When someone is needing some explanation and interacting with other human, we need to understand why they want an explanation. And what they want is really some concept, succinct, comprehensive type of mechanism to explain some decision. Usually, the explanation is very much context specific or scenario specific. And from the computer science point of view, and I'm a computer scientist, we need to have some measurement as how good that explainability is in terms of response time, accuracy, and user satisfaction. Now, what is explainable? As I said, it's context dependent, so you can't have an explainable system that works for everything. At least that's my thinking. In the automated vehicle context, we need an explanation when our mental model sees a discrepancy between what you see and what you are expecting. So this is very much what we've experienced when we did some experiment with the Zoe 2 that my colleague explained before, when they're sitting on the driver's seat and something happening, then if it doesn't correspond to their mental model, then they seek explanation. So we try to understand how we can provide that explanation to the driver. And usually someone is seeking explanation when they want a normal behavior, and that will trigger an explanation. When there is a problem in comprehending or predicting or anticipating what's happening. So this is very much in the area of a situation awareness. We have some expectation on what's happening in the environment, and when it's different from our expectation, then we seek explanation. When you see that there's a risk happening around you, then you seek some explanation. Now, most of the work in XAI or explainability AI failed to ascertain that the factor that influence the ability for the user to understand and reason about the explanation in a given context. So usually they just say, okay, this black box did that because of this, and that's it. It doesn't really look at all the contributing factor that influence that decision. And the most important things from the human factor point of view is that they wrongly hypothesize that the user who is reading or looking at the result have the cognitive and capacity to learn and adapt the output of that black box. And think about the situation in driving, a driving condition when you have to react quickly based on some warning or some input from a black box. So this is really illustrate what I'm trying to say. You are on an automated vehicle, something beeps, the car is doing something odd, and the driver or the passenger is wondering what's happening, why, and seek some explanation. So we had, I will now present a project that has just started. It has been approved. The aim of the project is to design and evaluate a human-centric, explainable automated vehicle framework grounded on human risk. As you know, when you drive and you regulate your speed based on your risk perception. And the framework that we are creating is grounded on that human risk perception and also what we call self-regulating learning. So I explain that a little bit later, but for example, when your car beeps in a certain context and it keeps beeping in that particular context, then you self-adapt. You might ignore it, or you might get bored of it after a certain time. So we take into account that psychological construct about self-regulating. And the whole idea here is that if the driver keeps asking questions and wondering about what's happening, it really decreases the acceptability of the technology. So what we want here is to increase the acceptability of the technology so that the driver trusts actually driving their driverless car. So this is how we did it. On the top, you have the mechanism that is used today in automated vehicles. So there is no explanation about why the automated vehicle is doing what it does. So it receives some input about all the sensors, and then you have that, I call it black box, using some machine learning type of mechanism that outputs some decision, and the driver here is confused and wondering why did the car do this. What we are proposing here is taking the same input, using the same black box. Why we use the same black box? Because, as you know, vehicle manufacturers are not going to open their black box. So we just need to reuse it and get the input and output, and get something from the input and output, and create some what I call human-centric logic here, and then output it with an HMI that will actually please, I would say, or reassure the driver, so that the driver understand and trust the technology. For example, again, with our automated vehicle level 4 that Sebastian presented, sometimes it stops somewhere in the middle of roundabout. We need to understand why. You can't just say, well, it stopped, and then you reboot, so to speak. So that's the approach that we are taken here. Now, I will go a little bit in details, but I'm not going to dwell too much about it. We had 3 studies to create that framework. So the first study here is about having a set of ethnographical and psychological, quantitative and qualitative studies about interviewing the driver about when, why, and how they want to have some explanation. What are the triggers? What are the kind of things they are expecting? And then once we have that, as you can understand, taking into account the kinematics of the car, taking into account the qualitative information, taking into account eye gaze directions and all that kind of things, we put that in study 2 here, where we have a machine learning mechanism that will learn and correlate somehow all those input to create what we call human-centric XAV logic. So that will tell you basically, explaining in a computational manner the when, why, how, and what type of explanation is required. Once we have that logic, then we will create the HMI related to it that will feed the driver so that it understands it, it validates it, it is satisfied with the result, it accepted and trusted. And one of the originality of what we're doing here is we address the ethical problem. For example, given that the explanation that you are giving here might be a little bit short and you need to be very, I would say, succinct. It means that you have to abstract something. And sometimes I'm not saying that you have to lie, but you need to have different type of way to convey that information. So is it ethical? So we will talk to philosophers and psychologists and all that kind of people to make sure that the final product here as an HMI human-machine interface is actually covering all those criteria that we want to address. Very quickly, I'm just coming back to this. I will explain very quickly what we do in this study 1 about when, why, how, and what kind of explanation is required. So we have a set of study in that a set of sub-studies in that first study. So what we are doing here is in our car, we actually started with driving instruction and a researcher here doing a manual driving and asking some explanation to a driving instructor about why a particular maneuver has been done. After that, we actually ask a naive user here to drive in automated mode, and he or she will ask some question to the engineer or researcher about the behavior of that particular driver, of that particular car. And then that will help us to actually have the model or all the paradigm that we need to construct the way things are explained in a driving situation. And again, here we take into account the adaptation and the risk learning when something is repeated and the driver is get habituated or used to a particular event. Just to I would say the dimension that we are addressing, you have horizontally the type of risk, no risk to a high perceived risk. And then on the other axis, you have something related, is it something that you can explain or something that you can't explain? So in terms of risk, if there is no risk, then there is some kind of risk tolerance, or you don't need to issue some warning. In terms of explainability, sometimes you can't explain things. So you have to navigate through that. And then you have to take into account the type of warning in terms of how accurate it is, how urgent it is, and how acceptable it will be. Now, that easy to say, but still, what is the challenges to make that AAV trustworthy in all possible driving scenarios? One of the things that we think is not going to be possible to address is that, as you probably know, driving situation is extremely complex. That's why, for example, the young driver takes 1 year or 2 to get their license. It requires lots of training. When they learn, there's some new emerging behavior, meaning that there will be some unstructured data that you have to feed a machine learning if you want to use machine learning to learn about that behavior. There's a lot of things about uncertainty too, and AI are not very good in dealing with uncertainty. And the other things, as you can also guess, is that we really need lots of data, and we need to include in simulation, and we should really avoid bias. One thing which is probably well known too is when you drive, it's not just, you don't drive like a robot. You have a common sense. And we know that AI doesn't have common sense. So this is something that we will need to address. As for the future of digital mobility, I think it was mentioned before that we will use a lot of big data, and big data will be shaping our mobility ecosystem. And we really need to ask the question, especially in driving situation where it's very critical to get it right. How can I trust an AI system inside the car or outside the car? How to make sure that it's safe, secure, fair, and it preserves our privacy. How to train an AI about safe behavior. If we can define what is safe behavior, it will be good, but we should try to teach an AI about what is safe behavior. And the other thing is when we have a crash, for example, policymakers, insurance want to know why and trace back the decision leading to a particular type of crashes. And talking to policymakers and regulator and looking at what the vehicle manufacturers and the people who are actually creating those AI technology, it's addressing that is very difficult, and there is too few incentives to allow normal people like me to verify a particular claim made by an AI related problem, and there is no incentives, for example, for an AI producer to explain why they arrived to a particular decision. So that will conclude my talk, and thank you very much for listening.